In response to this climate challenge, the 5-year Green Climate Fund funded project targeting supporting vulnerable communities in the Maldives to manage climate change-induced water shortages was launched by the government of Maldives in the year 2015. The accredited entity for the project is the United Nations Development Programme, and the implementer is the Ministry of Environment, Climate Change and Technology. This project has the objective to deliver safe and secure fresh water to 105,000 people in the Maldives in the face of climate change risks. Under this project, a consultancy service was carried under the title Assessing Groundwater Resources and Design of Aquifer Recharge Systems in Selected 17 Islands of Maldives, and this was 3 specific objectives as outlined. A. Undertaking baseline assessment to establish the current status and catchment characterization of each study island. B. Conducting feasibility study and developing concept design of managed aquifer recharge (MAR) systems for the islands with a specific emphasis on floodwater management. C. Detailed design for MAR systems. This video highlights general information about groundwater, how it forms, how it exists in the islands of Maldives, its usages, and how it is getting contaminated. Island features and characteristics related to topography, demography, hydrology, hydrogeology, flooding issues, and so on. What is groundwater recharge? Why do we need to recharge it? And what are the methods available to recharge groundwater artificially like the managed aquifer recharge system? Water. It is essential for all life on Earth. It covers approximately 71% of the Earth's surface, but of it, only 3% is fresh water. Fresh water can be divided into 2 categories: surface water and groundwater. Surface water is visible to us, but groundwater is not. It is located below the Earth's surface. What is groundwater? It is basically water from rain and rivers that migrates through the ground over time and stored in porous soils and rocks. The geological layer that stores groundwater is called aquifer, and it is generally referred to as groundwater aquifer. It is very important to note that the only natural freshwater resource in the islands of Maldives is a groundwater aquifer, which consists of freshwater lens that floats on top of a dense saline water layer. The freshwater lens is formed and recharged by rainfall that infiltrates and percolates through the island's soil layer. In Maldives, groundwater is mainly used for washing, bathing, gardening, agriculture, and industrial needs. Groundwater is also used for drinking in some islands, but it is less compared to the situation 20 years back. Dug wells are 100% used for extracting groundwater for non-potable use in most of the islands. Groundwater contamination. It is the phenomenon of human activity altering the chemical composition, physical properties, and biological characteristics of groundwater, resulting in deterioration of quality. Hence, there are many forms of groundwater contamination. For example, domestic sewage and water can contaminate groundwater with pathogens. However, the contamination focused under this project is salinity intrusion. Saline water intrusion, how it happens. As noted previously, the freshwater lens floats on top of a dense saline water layer in the islands of Maldives, and this lens is relatively thin and contains limited amounts of water. When groundwater is extracted excessively, seawater in the surrounding area of the island intrudes into freshwater and causes the freshwater saline water transition zone upwards. This results in saline water getting closer to the groundwater table. Increase of population, use of groundwater for irrigation and industrial use caused extracting groundwater more at present than in the past. This situation has aggravated lesser rainfall or uneven distribution of rainfall due to climate change.
ಅದೇ ಮಿರಟುಗೆ ಲೇತುದಿಯ ತಿರಿಸಾರುಗ ಮಾಜಿಯ ಬಾದಾರುಗ ಮಿರಟುಗ ಮೀ ಮೀಹು ಮೀ ಟೆಂಗ್ ಬೇಣು ಕುರಮು ಮೀ ಅನ್ನನಿ ಮೀ ರಫುಗೆ ಹಿಸಾಬ್ತೋಗ ಎಡಿಪುನ್ನ ಬಾಳುತತೆ දැන් ආමු ගොතෙක්ග මී මෙතෙන් බේරුම් කුරවේ ගුයිමෂා තෙන්බෙරුම් අදි කෙක්කුමත් මී බලතකුන් නගපෙන් බේරුම් කුරවේ එනමස් මිහාරකන් ඇස් හම පාහ කොල්ලෙවේ මී මීහුන් දිරියුලේ සරහද්දුගේ වලත ලොනුමා me me tekkuma bes beenun nukurave wara me tenuge raaju quality dakkama aamunge paratun shakwa libemun dakam paha kolla dena mesama pahuge tarihu taka jehenden avmenna me alan abadwa sarahadduge me hunna pembalu takun boima pem beenun kuremun dia namaves miharu avmenna me ala abadwa sarahaddu me pahum me godi du kurewunu sarahaddu tawge swartawga me nubෑ wahen hunna tomge shakwa avmenna libemunde den adege itura hama penuge kuda kommesaraka badal refa hunna tomge shakwa take libemunde den pahana kurumge nizama balaruga almen mege kuriga hama mi gondu dosha mi pantila beenu kurumundi rasen hennames miharu hama komme geggaves junction hadagen mi biman hinda nizame beenu kurumundani hennames mi allo iradu kurabbiya almenge mi kuriyam miyon aharu narudamage hidume gayam kurevigen diyam ekama vesama mi daimi edeve halden divigen daanakama alonda gabul kura adege itura mi RO plant behettigen daana miharu mi peshigen mida mashruge deren erun avmenna miharu mi pena dimag famaiwa massaden halden divigen daana
ಇದಕ್ಕೆ ಆಗಿಗದ ಕೊರಿಗ ಅರ ಫ್ರೆಂಡ್ ನೀರು ರಾಶಿ ರಾಜುಗೆ ಬಿಮವಾಡಿ ಫಸಲ ಫ್ರೆಂಡ್ ನೀರುಗ ಬೇಣುಕೊಂಡ್ ಹೇಳಿ ದೇವಾಸು ಮೀನು ಬೇರನ್ನ ಕೊರಿಗೆ ಮತ್ತೆ ಅರ ಅಲಂಗವಾರ ದೇವರು ಮೀನು ಬಾಳು ಬಿಡಿಕೊಂಡೆ ನೌಕಿ ಆ ಮಗುಗೆ ಸೆಳೆಗೆ ಹದಾಗಿಂಗೆ ನಾನು ಬಂದಿತ್ತು ತೊಂದರೆ ಅನ್ಕೊಂಡು ಗೋಶ ಕಪ್ಪಾಗ ವರ ಫ್ರೆಂಡ್ ನೀರು ಬೈಕ್ಗೆ ಕೊಸರಿ ತಕ್ಕುಗ ಮಲ್ಕೊಡ್ತ ಹದಾಪುನ್ನ ಮರ ತಕ್ಕು ಮಿಸ್ ಏರು ಫ್ರೆಂಡ್ ಬೇಣುಕೊಂಡ್ එගොතු මර ගෙන සමාන්තකවද ෆෙල්මින් බෑනුම් කරමු ඇස් දරුග පෙම්පසලෙන් අස්තු බදල් වන්නම් ෆෙෂින් දශුගේ එක හිසාබතකෝග ගේගේ නරුදමා හදන් ෆෙෂුණු හිසාබ ෆෙෂින් එහෙන් මඩුමඩුන් දමන් ගොස් අනෙක්ක ස්නාමී මර බොඩති බදල්තකේ රහුග පෙනන් ඒක පවුගම එක්ගොලකස් රහුග පෙන් දේරු නුකුරව ගෙන සරහදකතක මිහාරු ස්වරම් මදු බේග් ගනෝනි ගංගල පෙම්පොද ಫೆಂಬರಾದ ಮಿಸ್ ಮುದುಕಲ್ ನಂಗಸ್ ನೋಡಿಗೆ ತಗೊಂಡು ನೀ ಕಂಪಜಲೆ ಬದಲ್ತ ನನ್ನ ಮಿ ಪೆಸಿ ಗದ್ದತಿನ ದಮಂಗ ಸಿಂಗಾರ್ನಿಯತಿ ವರ ಬೊಡತಿ ಬದಲ್ತಕಂಗಸ್ ನೀದನ್ನ ವಾಂಗ ಪೆನ್ ಬೇರ್ನ ನಕುರೆ ವರ ಮದುಗೆ ಗನೋನಿಯ ವರ ಬೊಡತಿ ತಕ್ಲೀಫ್ ತಕ ಕಮಗ ಸವಮ ರಾಜಿತುನ ದಿಮಾವೆ ವರ ದುರುಂ ಕೊಡಲಾಗೆ ಹೊಳಿಯಾಳಾಗೆ ವರ ಮಸಕ್ಕತುಂ ಫೆಂಬೇಣು ಕೊಲ್ಲ ಗೇಗೆ ಸಗೂರ್ ದನ್ ದುವ್ವಾಚೆ ತಗಿನ ಮಗತ ಚಕಬಿಮಸ್ ರಾವಲತಿ ಅಡಿಯಂ ಇಂದನಿವಿಸ್ ಚಾಕ ಫ್ರೆಂಡ್ಕೋ ಇನ್ನೊಂದು ಹೆಂಗೆ ಅದು ದುರ್ಯಾಗತಕ್ಕೂ ಮರ ಬಡತಿ ಗೆಲ್ಲಿಂತ ಪೆಂಪದಲ್ಲಿ ರೆಪ ಹೊಡಿ ಹೆಂಗೆ ರಾಜಿತಿನ ಬಾರ ಬಡತಿ ಗೆಲ್ಲಿಂತ ಗೆರತ
Groundwater availability has a direct and indirect relationship with island characteristics and is also influenced by groundwater extraction rate and drainage facilities in the island. Let's look at each of these items in detail. Topography. It is generally flat with few low elevated and high elevated pockets in some islands. Elevation ranges from 0 to 2 meters MSL. Sand dune elevation at coast sometimes exceeds 2 meters MSL. Topography is one of the factors that influence groundwater recharge. Runoff will be slower in mild sloping areas and hence more possibility for infiltrating rainwater into groundwater aquifer. However, if infiltration capacity is low, then it will create water ponding on the ground surface, which will ultimately lead to flood inundation. Hence, food vulnerability will be high in such areas and will be aggravated if the stagnated water cannot be discharged to sea via natural ditches or stormwater canals. The other reason for flooding is high-density rainfall, large amounts of rainfall within a short period. Studies related to meteorological data analysis reveals that there is an increase in the rainfall intensity and extreme floods have been triggered by intense precipitation, which is one of the impacts caused by long-term global climate change. Rainfall analysis carried out for Maldives using the recorded rainfall data has also found similar findings. It has been noted that the frequency of seawater flooding, known as sea surge, is also increased in some islands, and it is another form of climate change impact. When seawater flooding and rainwater flooding occurs at the same time, the impact is very high. Island shape and width. Most of the island can be grouped into 3 shapes: round, circle, strip, and crescent. Island shape influences where deeper depth of freshwater lens occurs. For example, it will be in the center of the island for a round-shaped island. Island width influences average thickness of freshwater lens. When the width is smaller, seawater can intrude into freshwater easily. During field visits to the islands, it was observed that islands with smaller width had saltier groundwater. Geology and hydrogeology. General geographical profile in the study islands is composed of topsoil and beach coral sand deposits underlain by sandy coral rock. The sandy coral rock consists of weathered coral rock layers and hard fresh coral rock. The thickness of the coral sand layer is about 0.2 meters in the beach area, and it's about 2 meters thick in the middle of the island. The coral sand layer is mostly unconsolidated and permeable, and underneath of it there are weathered coral rock and fresh coral rock. Fresh groundwater lens occupies both coral sand layer and weathered coral rock. Hard coral layer is mostly unconsolidated and impermeable and present as a fresh rock. As per permeability carried out in the study islands, average percolation rate of the topsoil varies from 2.96 to 10.56 meters per day as per the field test. Lower percolation rate will cause lesser water moving into groundwater aquifers. Water extraction. Groundwater is the only source of water for non-potable use in all islands studied under this project. As per survey data, groundwater in these islands are high, ranging from 292 liters per day per person to 421 liters per day per person. This consumption rate is comparatively high and would cause upconing saltwater-freshwater interface. Sanitation system. Currently, sewage is disposed by means of septic tanks in 5 islands, and a sewer network and pumping stations is used for the same in Diamigili and Omandu islands. Usually 80 to 90% of extracted water via an infiltration process if the wastewater is not collected via sewer network and pumped to sea. However, when such a system is in operation, infiltration of used water into groundwater aquifer will greatly be reduced, and it will cause rise in saltwater interface upwards. Groundwater recharge. We have already understood what is groundwater, how it occurs, and its relationship with island characteristics. Now let's look at what is recharging groundwater, why it is required to recharge the groundwater, and what the available methods are. What is groundwater recharge? Recharging groundwater is a process of surface water entering into groundwater aquifers, and it can occur both naturally or be influenced by human activities. For example, rainwater entering into groundwater through porous soil and cracks in rock is a natural way of recharging groundwater, whereas injecting water to aquifer through deep or drilled wells is known as an artificial method of recharging groundwater. Why do we need to recharge the groundwater? The amount of water stored in the aquifer is limited, and when groundwater is extracted excessively, groundwater table goes down and saline freshwater interface moves up. In such a situation, water in the well gradually turns salty. The basic purpose of groundwater is to increase groundwater availability in the aquifer and to prevent freshwater turning into saline water. Some methods of recharging groundwater will improve its quality. One of the key advantages of groundwater recharging systems is mitigating flood or reducing flood inundation. There are several methods of recharging groundwater. Rainwater harvesting and infiltrating it through the well. Runoff from roof is diverted to existing wells which are being used for daily use of non-potable water usage. Water in dug wells will partly infiltrate into ground through the well's bottom and side wall provided that they are not sealed. It has already been practiced in some islands of Maldives. Injection well. Runoff from roof or drain will be diverted and injected to deep aquifer through borehole and stored it there. Aquifers on islands belong to the category of shallow, unconfined aquifers, and therefore rate of infiltration will be very small. Island's topography doesn't support diversion of large quality of water from ground to injection well. Vegetated swales. Both rainwater from roof and runoff from land can be diverted to it. Swales slow runoff, filter it, and promote infiltration into the ground. It is very eco-friendly and highly preferable from an environmental point of view. Width of the road in the island is generally not adequate to construct swales. In case if vegetated swales are to be constructed at isolated locations, means of conveying the rainwater to the proposed site needs to be developed. Dry well. It is the concept of recharging aquifer based on gravitational flow through the wells. It is similar to rainwater harvesting system, but water is not stored for long period and it is designed to drain to ground at 48 to 72 hours. It is to be constructed in the Vadose zone and runoff is fed to dry well through pipes. Overflow arrangement and inspection holes are provided in the well. Dry well bottom is to be placed at 0.6 meters above the seasonal high groundwater level, but the water table is shallow. Infiltration drain, pit, basin. It is similar to a dry well, but surface water is diverted to it through natural ditches. Drain, pit, basin stop is open to air and a berm can be constructed around it to prevent sediment entering it. Infiltration drain pit can be constructed on roadside or road middle if it is with 2 lanes. Infiltration basin is to drain a large quantity of water. Existing valleys or depressed areas are usually preferred for this option. Since such an area is not available at the project island, it has to be artificially created. Space availability for such basin construction is a major constraint. Runoff from roof can be diverted to it.